Okay, let's jump right into this explainer and tear down a brilliantly simple minimum viable product, an MVP that digitizes an entire rural supply chain using, well, almost zero infrastructure. Now, if you've been following along with our Build With Me series, you already know we're actively architecting the MaziwaLink app. That's our enterprise milk web app tailored specifically for the Kenyan market. And to get our MVP4 absolutely right, we are using an incredible research paper on an Indian system called DMilkRoot as our ultimate blueprint. This source material is just perfect. It illustrates exactly how to build a highly functional, deeply resilient supply chain tool for those rugged environments where our typical tech assumptions just completely fall apart.
So here is the million-dollar question we've got to ask ourselves. How do you digitize a massive supply chain without the internet? Seriously, think about it. This is the ultimate constraint-driven design challenge for anyone building for low connectivity environments. Whether you're in rural India, like the source text explores, or in the rural Kenyan dairy communities we are targeting with MaziwaLink, you absolutely cannot rely on stable cellular data. You literally have to assume the network is going to fail.
To break this down, we've got 5 quick sections today. First, the rural dairy dilemma. Second, the single-file architecture. Third, grading and payment modules. Fourth, overcoming hardware limits. And finally, scaling to production. Let's get into it.
Starting with Section 1, the rural dairy dilemma, in the absolute chaos at the collection point.
Let's ground ourselves in the baseline reality of rural milk collection. In India, we are talking about over 80 million farm households. And despite that massive scale, if you visit a collection point at, say, 6 a.m., it looks exactly like it did 30 years ago. We're talking chaotic, fragmented manual processes, handwritten paper ledgers, cash stuffed in pockets, and quality readings just shouted across a noisy, crowded room. Plus, farmers often wait days just to get paid, with no real way to verify the math. DMilkRoot completely flips the script here, moving everything to a unified digital interface with digital logging, automated grading, and instant payment capabilities.
But here's the thing. It's not like technology didn't exist before this. There were Bluetooth milk analyzers, SMS alerts, tablet terminals. But the recurring frustration wasn't the tech itself, it was the fragmentation. It was like having a bunch of puzzle pieces that didn't snap together. The collection agent constantly had to bridge the gaps manually, basically copying data from one tool into another. That friction is exactly what DMilkRoot and our own MaziwaLink project seeks to completely eliminate.
Which brings us to Section 2, the single-file architecture. This is a total masterclass in constraint-driven design.
This is the true aha moment of the DMilkRoot solution. They threw conventional server dependencies completely out the window. The sheer simplicity of this tech stack is honestly mind-blowing. Get this, the entire system is just one single, roughly 6,200-line HTML file. It uses standard HTML5, CSS3, and vanilla JavaScript. For saving data, it relies purely on the browser's local storage API. There's no fancy backend framework, no package registries to download, and absolutely zero server dependency to make the core features work.
Zero IT setup required. You literally just open a file in a browser, and you're good to go. By stripping away package registries and network round trips, this MVP takes the massive weakness of no internet and turns it into the superpower of instant load times. For our MaziwaLink MVP4, adopting this kind of zero-install, single-file approach means we can deploy our app to a collection agent's tablet instantly, no matter their technical skill level or how spotty their connection is.
Moving right along to Section 3, grading and payment modules, and how this all fits into the operational workflow.
So, how do we translate that simple code into an agent's actual frantic morning routine? The system organizes operations into a rapid-fire 4-step loop. Step 1, the agent selects the shift and the route. Step 2, they select the farmer and punch in the milk volume and quality. Step 3, the system instantly auto-grades it and computes the bill. And Step 4, it processes the payment. Boom, boom, boom. This loop has to happen over 130 times a morning before the milk literally spoils in the heat. And this interface? It lets the agent do the whole shebang without ever switching apps.
Now, the automated grading is super interesting. The researchers built a strict rule-based engine that instantly calculates payouts based on fat and solid not fat, or SNF thresholds. For instance, cow milk needs a minimum of 4.5% fat and 8.5% SNF just to hit grade A, which earns 34 rupees per liter. The developers deliberately chose this super straightforward, transparent system over some complex black box algorithm. Why? Because a farmer standing right there at the collection point needs to understand exactly why they got grade B instead of grade A. Transparency is what builds trust, plain and simple.
And crucially, the system then simulates instant settlement via UPI, which is India's unified payment interface. It pops a visible receipt right there on the screen. For farmers who rely on milk for their daily survival, completely removing that agonizing 2 to 3 day wait for the cooperative to do the math, that is life-changing. For our Kenyan context with MaziwaLink, this is exactly where we'll simulate an instant M-Pesa mobile money disbursement. Same massive impact.
Okay, let's talk real-world specs in Section 4, overcoming hardware limits and performance in the field. Building a lightweight app is great in theory, but how does it run on the cheap hardware an agent actually carries? Well, 1.8 seconds. That is all it takes to load this entire application from a local file on a pretty standard, mid-range Snapdragon 680 Android tablet. To break those speeds down even further, after that initial 1.8-second load, rendering a farmer list of 137 entries takes just 0.6 seconds. Rendering a collection log with 50 entries, a mere 0.3 seconds. Sure, these numbers might not sound mind-blowing for a modern desktop PC, but context is everything. For an agent standing outside at 6 a.m., sweating over spoiling milk and expecting terrible digital lag, this offline first speed is a total game changer. It makes sure the tech never, ever slows down the human.
Finally, let's wrap up with Section 5, scaling to production and addressing the MVP limitations.
Because look, while this single-file HTML approach is a brilliant MVP blueprint, the developers are very upfront about what has to change before a massive real-world rollout. The biggest red flag? Data fragility. Local storage has zero redundancy. If that tablet resets or the browser cache gets cleared, poof, everything is gone. That is absolutely unacceptable when you're handling people's daily income. So, to scale this, which is our ultimate goal with MaziwaLink, you've got to replace local storage with a proper offline-first progressive web app backed by a cloud database like Firebase or PostgreSQL that syncs in the background. You also need real payment gateways, actual IoT sensor integration using a lightweight protocol like MQTT, and multi-user authentication so the data stays secure.
I want to highlight this quote from the conclusion of the research paper because it really hits the nail on the head. Agricultural digitization tools fail in the field, not because the technology is wrong, but because the deployment assumptions are wrong. That right there summarizes this entire explainer. Assuming you'll have a stable server connection, assuming an IT guy is nearby, assuming you have constant power, those assumptions will burn you in rural settings. You have to design for the constraints.
So I'll leave you with this thought. What deployment assumptions are quietly setting your next tech build up for failure? Take a page out of the DMilk Roots playbook. Constrain your environment, and simplify your stack down to the absolute essentials. We are going to be applying all of these lessons to our MaziwaLink MVP in the next part of this explainer series, and I guarantee it's going to change how you view offline first design. Thanks so much for hanging out with me today, and I'll catch you in the next one.